Okay, so we're going to continue looking at multiplying our radicals here. Whenever I look at a problem, I always check the numbers inside my radicals and see if there's any quick, easy, perfect squares that fit inside of those numbers or divide into them. I don't see anything with 3. I also don't see anything with 51, so I am going to multiply these radicals together, and then I'll simplify that. So when I take 3 times 51, I end up with 153. So right now I have 153, and then x times x squared gives me x to the third. From here I have to figure out a perfect square that divides into 153 evenly. So I'm going to go back here, take 153, you can try 4, that doesn't work. My next one is 9. That one does work, so I'm going to do 9 times 7. So I'm going to split up 153, and I'm going to turn it into 9 times 7. Also, remember, you can't have odd exponents, so I'm going to fix that and make it x squared and then x. So let's highlight everything that we are about to simplify, and we take the square root of 9, which gives us 3. If you take the square root of x squared, half of 2 I know is just 1, so I just have x, and then I'm left over with 17x. These two terms in there that I didn't use stay inside our square root symbol. So for number 4, there we go. There's your simplified version of that multiplication problem. Let's take a look at question 5. So for question 5, same thing. You don't have to multiply them together. You can look at this and say, I know that 20 has a perfect square inside of it. I'll go ahead and do that. So I'm going to rewrite this as -3. I'm going to rewrite 20 as 4 times 5. And then I have the square root of 15, but I know 4 doesn't go into 15 and 9 doesn't, and 16 is too big, so I have to stop there. I'm going to fix that, so I have -3 times 2, and then I'm going to go ahead and multiply these two together because they're both in square root, so I'm going to do 5 times 15 because both of them are still in that radical there. So I'm going to multiply those. I know that -3 times 2 is -6. And 15 times 5 gives me 75. And then I got to keep going, so always check this number inside your square root and see if there's anything, a perfect square that divides into it, which there is. I know that 75, if I have 3/4, I have 75 cents. So I know that 75 is 25 times 3. I'm going to simplify that. -6 times 5 times the square root of 3, and then -6 times 5 gives me a -30 root 3. All right. And again, you don't have to take care, like I just took care of the 20 first, and I split that up into 4 times 5. At the very beginning, you can do 20 times 15 and get 300, and then split up the 300 into 10 times, or 100 times 3. So you'll get the same answer no matter which way you do it. Let's take a look at number 6. So same thing here. I'm going to check to see if I can find any perfect squares that divide into either of those numbers, which I don't see any. So I'm going to combine or multiply them together. 6 times 3 is 18. A to the third times A gives me A to the fourth. Now I'm going to split up my 18 and think of a perfect square that divides into 18. I know 18 is 9 times 2. And then my variable, I'm just going to leave it like this because it has an exponent that is even. So I'm going to leave it like this. Let's highlight what we are about to take the square root of. I know the square root of 9 is 3. And then I know half of 4 is 2. So I have A squared. And then this 2 stays inside the radical. So keep it in there. And then last step is to just multiply -2 times 3, which gives me -6, A squared root 2. All right, let's go and check those 3. Make sure you got them. And we'll try a couple more together. Let's take a look at the next page of your notes and try some of these ones together. Let's try some of these bottom ones down here. Let's do these bottom ones down here. So I'm going to look at these numbers and see if there's anything I can fix. I'm going to treat these separately. That way I'm going to have smaller numbers to multiply instead of multiplying them together and try to find a bigger number that divides into it. So I know that 32 can be divided into, let's see, 4, let's do 4 and 8, let's check 9. Oh, 16, let's do 16. 32 is 16 times 2, and then I have x squared y squared, and then my 18 is 9 times 2, x y to the third. Okay, so I'm going to fix this and fix this, and I'll wait to do all my exponents later. I know the square root of 16 is 4, I know the square root of 9 is 3, and then everything else that's left over, all of this stuff, all of this, and all of this, I'm going to multiply it in here. So I have a 2, I have an x squared and an x, I have a y squared and a y to the third. So that's everything inside my square root there. Okay, so I know that 4 times 3 gives me 12. And then inside my square root, I have 2 times 2 is 4, x to the third, y to the fifth, which I'm just going to have to break those up anyways. So 3, 4, 5, there we go. All right, so from here, I know I can fix this because the square root of 4 is 2. So I'm going to do 12 times 2. Then I'm going to rewrite my exponents as, or my variables as x squared x and y to the fourth y. And then from here, let's fix our variables. So with my variables, 12 times 2 is 24. Half of, well, x, the square root of x squared is just x. The square root of y to the fourth is y squared. And then I have xy still left over in my radical. There we go. So final answer, 24xy squared equals this, 24xy squared root xy. And if you want to, up here, you can take care of the variables up here if you want to. I just combined them together and then took care of the variables, but either way, you're going to end up with the same answer. All right, let's try one more of these together. So let's try number 12. Again, if I can see that there's some perfect squares inside of these numbers, I'm going to deal with those first. So I know that, well, the 15, I'm going to leave this as 15x to the third. I'm going to rewrite 18 as 9 times 2, x squared. And then I'm going to rewrite 12 as 4 times 3, x squared. Unlike that last one, I'll go ahead and take care of the x, or the variables, and my perfect squares. So I'm going to take care of everything that I'm highlighting right now. So my 15x to the third stays. I know that the square root of 9 is 3, so I'll bring that out front. The square root of x squared is just x. Let's look back here. Square root of 4 is 2, so I'm putting all of this in front. And then the square root of x squared is another x. So lots of things out front that I am taking care of. And then notice in my square roots here, my 9 and my x squared are gone because I moved them here. But I still have a 2 left over, so I still have to make sure that I keep my 2 inside my radical there, so keep that there. And then also look at your other one. The 4 is now a 2. The x squared is now an x, but I still have this 3. So I'm going to also keep my 3 right here. And then from here, let's fix this stuff. So 3 times 2 is 6. Let's see, x times x gives me x squared. And then let's do 15 times 2 times 3 is going to give me, I know 15 times 2 is 30. 30 times 3 is going to give me 90. And then I'm going to rewrite x cubed as x squared x because I need an even exponent. I'm going to rewrite my 90 as 9 times 10. I got x squared. I got x. Let's highlight everything that we can take the square root of. So I know I'm going to have 6x squared times 3 times x because the square root of 9 is 3. The square root of x squared is x. And then in my radical, I have 10x. And then lastly, let's fix this stuff up here. So I know that 6 times 3 gives me 18. I'm doing x squared times x, which gives me x to the third, and then I have root 10x. All right, let's box this in. And then again, there are lots of ways you can do it. You can take care of your variables at the beginning, like I did. You can multiply your variables, so have x to the third, x squared, and x squared, and you'll have x to the seventh, and then take care of it. Either way, you'll end up with the exact same answer. So I got 18x to the third, root 10x.